Okay, so this exercise is about using Jupyter notebooks on JASMIN on this tool that's known as the JASMIN Notebook Service. We didn't have much feedback from people about this, so I'm hopeful that people got on okay with it. So at the start, we just talked about the reason why you might want to use a notebook service. So one of the great things is you don't need to do anything with SSH keys. You don't need to be in a terminal window or anything. You just need a web browser and you have your programmable interface. We have a version of, which is slightly behind the main version on the terminal system, a version of the JASMIN packages. We're going to update that soon. You can read directly from the CEDAR archive, which we'll demonstrate. And one of the really nice things about notebooks is that you can, as well as being able to put outputs and visualizations in there, you can put documentation interspersed with your code and your outputs. So it's like a real, almost like you can almost have a scientific paper written in a notebook in one respect, or certainly it's like a scientific notebook. So in this example, we're looking for some ECMWF era reanalysis data, and we are just grabbing some hourly files for a single day of 2-meter temperature, of generating some plots, writing some data to JASMIN in NetCDF, and then annotating the notebook. So if we scroll down to the cheat sheet, the first thing it says is go and log into the server. And the first thing that does for many of us is it says that we need to do a 2-step verification. So that will have sent me an email, and fingers crossed that email will come through very soon. I'll delete these while I'm here. Okay, here's my verification code. 6-digit code, put the verification code in, and I verify. And then this goes away and it starts up my instance of the Jupyter Notebook service. So just for background information, this is all running in what are known as containers. So using a tool called Docker, and all of this is managed by an orchestration tool and deployment tool called Kubernetes. So each user gets their own little ring-fenced amount of CPU and memory, which can also be expanded with an overall constraint. So I'm lucky here because I've gone straight into the pre-canned notebook, which is available on the Git repository. So instead of doing typing along the way, I'm just going to talk through this. So I'll put this into full screen mode. And again, feel free to pipe up if you have any questions or thoughts. So one of the key things we get onto at the end is talking about how it's really nice that you can put formatted documentation in. So these first couple of cells here are just markdown formatted documentation. I can double click to edit them, and I can shift and enter to execute them and turn them back into nicely formatted content. So the task here was to find a set of files, NetCDF files, and read them in. Now, the blurb here tells you that you can find this information out by searching the CEDAR catalog. In the CEDAR catalog, you can find this catalog page. Maybe I'll just show you that. And so here we can see information about the data set and different aspects about the temporal and spatial characteristics. If I click download, I can then scroll through and actually find out what the directory structure looks like. And so from doing something like this, I can find out what the files are called and what the directory structure is. And then within my Jupyter Notebook, I can convert that into a path that I can access on the Seeder system. So here I found out this URL points to this directory. And if I take off this prefix here, the bit that just starts with /BADC or /NEODC is going to be data in the Seeder archive. So I've worked out that this is a valid path to get all the 2 meter temperature data for the 1st of January for 2005. So this is global data, and these are surface analyses from the ERA 5 data set. So my first code cell here, and we can tell it's code because up here it says code, imports the X-array library, which is a really useful library for working with NetCDF and multi-dimensional data sets. So I import that, and then here I set up the file pattern that I want to read from. And there are two different ways that I could do this. I either set up the file pattern, or I could write my own little function that can take in a year, month, day, and variable name. So instead of hard coding these things, I can write a little function that will generate a template and get me back whatever I want. And if I do that, I can send in the year, month, day, send in the variable ID, call get template, and I get back this file pattern. So that's just a more elaborate way of setting up this thing, but doing it in a flexible way that I can then reuse for different time steps and for different variables. One of the things I want to check is that I'm definitely going to find some files behind this file pattern. So I import the glob Python module, and I've just called glob.glob with that pattern, and then got the length of that list. And that tells me there are 24 files. So that's good because it's hourly data. So 24 in a day. I think that will work. So the next thing I want to do is I want to use the X-array open multi-file dataset function and send it my pattern. And I run that. And what this does is it reads the headers of all the NetCDF files, and it merges it into a single object. So DS here is just asking me to print out what that object is and display it within my notebook. So in this results cell, it's giving me an overview of what this data set looks like. It tells me that there is one data variable, which inside the X-array is called T2M for 2 meter temperature. And it's got these coordinates. So that's the grid and the time axis. I can find out a bit more. I could say, well, I want to know what the NetCDF variable attributes are for 2 meter temperature. And that gives me back an ordered dictionary of keys and pairs. So it tells me what the units are, tells me what the long name is in the NetCDF files. And if I particularly want to look at one of the coordinates, I could look at something like time directly in this data set. So ds.time will access the time coordinate. And if I use the values attribute, it gives me an array of all the date time values. So again, this is the 1st of January 2005, going through from midnight all the way through to 11 p.m. So I now have a single object that I can work on, this X-array data set, in order to do some data processing, analysis, and visualization. So the next thing I'd like to do is I'd like to basically get the, pardon me, I want to get a map of or a 2D array of the maximum and the minimum values across all the hours of the day. So the time axis is axis 0, which we can specify here. And we can just literally call a max and min method on this variable within the data set. So I run those, and I just want to make sure that I've got rid of the time axis. So if I just look at the shape of the daily max, and the shape of the daily min, we can see here that they are 2D, and that's very useful. If I had a look just at daily min, we can see it's just defined against latitude and longitude here. and its shape is 721 by 1140. Okay, so we've now got daily max and daily min variables. So we've done some analysis of the data. I now want to do some plotting. Now, it's not always the case on our service that you need to do this matplotlib inline incantation, but it's generally a good idea. Sometimes some of the plots don't appear first time. It's a little bit random, so we recommend you do this. So the plotting is done with this tool called matplotlib, and this special notebook function with the percent sign just says I want to embed plots in line within my notebook. So now we can just call the plot method on daily max, and it goes away, it reads in that 2D array, and it generates an output plot. And here's one of the great joys of using a notebook, is that your outputs appear interspersed with your code and with your documentation. So there we've got a nice plot of that. We can plot the min, and then down here we've even subtracted the daily min from the daily max and generated a plot of the difference variable. So what this highlights here is that even though we're operating on an X-array data array or variable here, this daily max and daily min thing, we can still do arithmetic operations on them. So we can subtract one from the other. The object we have, this diff object, is still a complex X-array object that has coordinates. It knows about latitude and longitude. It has attributes, but the actual numeric arrays have been operated on, and we have this different output here. Now, another thing to demonstrate on the JASMIN notebook service is not only can you read directly from the CEDAR archive from /BADC or /NEODC, you can also write outputs to your home directory. Now, your home directory has a quota of 100 gigabytes. So there's quite a lot of room on there. So as long as you're not writing hundreds of gigabytes, you should have space to write a fair amount of outputs. So this is just a bit of work done here in Python to make sure that we have an outputs directory to write to underneath your home directory. And then these X-array objects, not only do an X-array data set, not only does it have a plot method, it has a to_netcdf method. So here we can just say, I want to write a netcdf file to the output directory /max t2m.nc. Can do the same with the min file. And here I'm just going to list the output directory, and that's confirmed that we've written these two netcdf files. So we're just demonstrating there that we can read from the CEDAR archive. We can also read from group workspaces that you can have access to, and you can write to your home directory. And then the final point we looked at here was this idea about markup. So I don't really need to go through this because you've already seen it as we've been working through. But you can go through anywhere and you can add more documentation. So let's say I wanted to add something underneath this cell. I can just I clicked on the cell, I click the plus button here. I then convert this to Markdown, and I could say heading 1, heading 2, list. And you've got full HTML style formatting within there. Now, luckily, this brings me on to some of the things that were in the further questions. So one of them is, if you want to delete a given cell, you just highlight it. Sorry if I click that again. Highlight the cell, and then you can just press DD on the keyboard, and it deletes that cell for you. Another thing that we mentioned in the exercise is that there are different ways in which the notebook will respond to you executing a cell. So you can press Control Enter, Shift Enter, and Alt Enter. So if I'm sitting in this cell here, if I press Control Enter, what you'll find is that I'm still focused on the same cell. So you can see each time I press Control Enter, the blue line is here. It's still highlighting this cell. Okay, if I press Shift and Enter, the focus moves on to the next cell. So Shift and Enter is quite often used when you want to go through and execute a number of cells at a time. So if I do Shift and Enter here, you can see it's stepping through a cell at a time all the way through. The last one is Alt and Enter, and Alt and Enter will always generate a new cell underneath the one that you're in. So if I keep pressing Alt and Enter here, you'll see it executes the current cell, and then it creates a new one underneath and brings you into it. Now, all of those are mentioned in the exercise itself. So just delete these, DD each time. And just briefly come back into the exercise here. So this exercise tells us how to get started with a notebook service. We're able to import and work with software packages. We've shown how we can read and write from the JASMIN file systems. We've known how we can view visualizations and annotations in line, and outputs as well. So we can show things like pandas data frames. They get rendered as tables in the page, and things like X-array data sets. Just a few things in terms of different approaches you could take. There are lots and lots of different notebook services out there. Most of them are completely free. One that you might be interested in looking at is the Google Colaboratory. So that has a lot of its own tools and data sets built in the same way that we have our own software environments and access to data built in. There's a really useful tool called Binder that allows you to take existing notebooks on GitHub and then run them directly in the cloud. So you can go from a GitHub URL to firing up a Binder instance and look at it in the cloud and interact with it. And it's worth remembering that one of the real strengths of notebooks is sharing them. So I really recommend thinking about viewing notebooks on GitHub and sharing them with other people on GitHub. I'll open up an example here. It'll probably take a moment to load. But just to say also, there are some links here. So we have more tutorial notes about different things you can do here in this tutorial notebook. And we have help pages about our notebook service. Just to show you what these things look like in GitHub, here's just an example of one that we created. And you can also, in GitHub, you can save the outputs as part of the notebook, or you can clear them all out. So in this case, they're saved, so you can see the outputs as well as the code itself. And I think the last things we've got right at the bottom here, which I won't dwell on, but they're just about adding extra software to your notebook. You can create virtual environments on top of notebooks. You can also create your own Conda environments and make them accessible to your notebooks. So if you go to either of these links, they talk you through how you can add a virtual environment within a notebook and activate it within a notebook. And then this example talks about creating a Conda environment in the JASMIN terminal and then making it visible via the notebook service. Okay, I think that's probably enough from me for now. Are there any questions on that before we move on?